All right, so this is page 9 in the packet. It's the last question from lesson 2 that we didn't get to in class, so I just wanted to go over this. It's a good one, and it does show up a lot on the AP test I've seen, so I just want to make sure we're comfortable with it. Given this function, I want to find a and c so that f of x is differentiable at x equals 1. Now, just like in the past, we've seen a lot of these questions where we're finding a and c or a and b. If you're finding two values, then you need two equations. Now, here's where that big piece comes in. If it's differentiable, and they want me to make it differentiable, then what has to happen? Well, in order for this to work, then it must be continuous. So I need to make sure that this function is continuous so that I can then force it to have a derivative there, okay? So if I want this to be continuous, then I need to find the points on the original and see what's going on here. This is an open circle at -1, and if I sub in a -1 here, let's see here, -1 squared, 1 times 2, 2 plus, so 3. And then down here, I would have a closed circle at -1, and if I sub that in, I'd get -a minus c. Okay, so now, in order for me to force the continuity, because I need it to be continuous, then I need these 2 points to be equal when x is -1. So I need 3 to equal -a minus c. I need that to happen to make it continuous. Now, there's one equation, but I need a second equation. So now, I just forced it to be continuous. Now I'm going to force it to be differentiable, which means I have to take a derivative. Remember, it's a calc question, guys. We got to take a derivative every time. If I take the derivative of the top piece, I have 2x squared plus 1, so the derivative is 4x, and that's when x is less than -1. And then if I take the derivative of the bottom, I get 3ax squared plus c, and that's when x is greater than or equal to -1. So if I want this to be differentiable, then I need to figure out what these points are. I would have an open circle here, -1, -4, and then here I would have a closed circle at -1, and then that would give me 3a plus c. So in order for me to force this function to be differentiable, I need these two values to be the same. So I need -4 to equal 3a plus c. If those are the same, then I have a derivative at -1, which is the whole point of this. And I have the equation from above, which I can bring down. I've got 3 equals -a minus c, and look at that, it's already set up for me. I don't even have to multiply by anything because my c's will cancel. So I can line these up and add them. A equals a -1/2, and now I can sub in. I've got 3 equals -a minus c. So 3 equals, look at, I have this negative here, and a is a -1/2. So what does that really mean? Well, that's a +1/2. So I'm going to add c over. I'm going to subtract 3. So then c is equal to -5/2. And we're all set.